Hi, welcome you again. I'm Sabir. So in this lecture, I'm going to teach you about components of a tensor. So today's lecture is about components of a tensor. Okay, so before going to teach you all about that, I need to make you understand about the base vectors. So I hope you all about know the base vectors. Base vectors are nothing. Base vectors are all the unit vectors of a Cartesian coordinate system which are perpendicular to each other, right? So here, if we say this is the x and this is the y, and is another is j direction j. So if we have unit vectors along the x and y, it's u1 along x-axis, e2 along y-axis, and e3 along z-axis, then the base vectors are nothing but is e1, e2, and e3. So these are the base vectors, and these are the base vectors. That means the unit vectors are base vectors which are perpendicular to each other. And the components of a vector depend on a base vectors used to describe the components, and this will be true for tensor. Okay, so consider a transform tensor T, and which transform the base vectors e1, e2, and e3. So if this transform e1 to another vector, then we can write down is t e1, right? And if we transform this e2, then we can write down t e2. And if we transform this t3, then we can write down t3. Then and this t e1 is nothing but it t transforms the unit vector e1 to into another vector which has a which have which have uh, which has components along x-axis, along y-axis, along z-axis as well. So how we can write down this? So we can write down here. So you can change the color here, and you can go up. Yep, yep. So we can write down here T E1 equal to T11 E1, right? And plus T1 E2 plus T31 E3, right? And then T E2 equal to T12 E1 plus T22 E2 plus T32 E3, right? Yeah. So T E3 equal to T13 E1 plus T23 E2 plus plus T T3 E3. So we can in short form, we can in compact form, how we can uh, write down this is of the vectors here. So in short form, we can write down here T E1. So here say we say the second indices of T is one and one, which is equal to the indices of T E1 here, right? And the first indices of T one is 2 and 3, which is equal to the indices of E here, right? So we can write down here uh, um, so T J, say if we say it is J, right? And say is 1 and E J, right? So same way we can write down T E2 here, T J2 and EJ, and we can write down here T E3 equal to T J3 EJ, right? So so we have got three compact form notations from these three equations, and in more shortened form we can write down three equation here, because you see the indices of T1 is equal to the second indices of T, right? So if we say it is I, then this should be also I, right? Okay, so we can write down T EI equal to T J I T J I E J, right? So this is the most shortened form of the three equations of that here, right? Here, yeah. So what is TJI? So TJI equal to here we found here T11, T21, T1, T12, T22, T32, right? Yes. So we can hear T 1 3, T 2 3, and T 3 3 here. So this is a TJI tensor, right? So if we write TIJ form, see the TJI is bit reverse form. So if we write on T transpose or TJI, then we can write on TI equal to J. Then we can write on the preceding equation Tij and something like that. So we write Tij equal to T11, T12, T13, right? And T21, T22, and T23, T31, 32, and 33. So we get the Tij, right? So these are the every components of this tensor. These are the components of tensor, right? So we see how tensors are related to base vectors here. So these are base vectors and these are components of T, right? So tensor, and this tensor, that means T or Tij, or you can write even T, it's called the matrix of tensor. So most interesting of this tensor is that if we correlate this tensor T to the system applications here, we see that the first column here. So I'm changing the color to make you visualize more effectively. Yeah, yeah. So here the first column here, right? This is the first column here. Uh, T11, T21, and T31 is nothing but the TE1, right? And the second column is, so it is the TE1, and is the TE2, and is the TE3. So these are the components of a vector or something, components of a matrix or something like that. So this I'm sure is very easy to you to understand all about that. So to make you understand more perspectively of the components, I'm going to give you an example. Give you an example from the introduction of container mechanics of that book that I'm following. Um, the problem number here is 2.7.3. Here we are asked that um, we, uh, we are asked that we have to find out the rotation matrix R, rotation matrix or rotation tensor R, right? So what is R? R is corresponds to a right hand rotation of a rigid body, right hand rotation, right? Right hand rotation of rigid body about the x-axis by a theta angle, by angle theta. So you have to find out what is the components of R. So okay, I'm going to draw a picture here to make you understand. Yeah, so say for example we have a coordinate system here, uh, x and y, y and z, right? Here, so this is an E1, it is an E2, right? And it is the E3. So we are asked, or we are said that R is a rotation matrix. That means R rotates the coordinate system. This whole coordinate rotates by the amount of angle theta, uh, by the amount of t with about to et or gx. That means we don't have to change. There will be no change. There is no rotation of E2. That means E1 should be transformed this year by the amount of theta here, right? So you can write them E1 prime or R E1. That means the rotation R rotation matrix R transforms E1 to E1 prime, right? So and the y2 axis, that means y axis will also be changed here by the amount of angle, same angle theta here, theta, right? Same angle theta. So it is, say for example, it is e2 prime, that means r e2, that means this rotation changes this e2 vector to e2 prime vector. So we have to find out this r. So what is the components of r? Okay, to make you understand, and I'm going to draw a picture, something like that, so how we can more easily how we can understand that. Okay, change the color here, right? So um, okay, so rotation of r3, rotation of re3 is the same, because uh, we are asked to change rotate the whole body about the about the e3 axis or something like that, about the g axis or e3. That's why it doesn't change, but e1 it would be changed by the amount of angle theta, right? So re3 would be the same, equal to the re e3, right? Okay, so to make you understand what are the components, to find out this, I'm going to draw another picture to make you understand that rotational transform. Let's draw current system. Say it is um, say e1, and we have to find out this e2, right? Yeah. So for if it is e2, we do not draw e3 because it doesn't change. So it is r e1, right? And it is r e2. So we have to find out the components of r. So this is the amount of theta. So this is the amount of theta. So we draw a another line here, for example here. So you have to find out these positions here. So if we draw yeah, if we draw a line perpendicular to this, so this is 90 degree, right? Yeah, so and perpendicular to this, so this is 90 degree. So okay, and we have two triangle here. So this is, say for example, is a, here it is b and c, and b, d and e, right? Yeah, e. So this equation and this equations are identical, because this angle and this angle are same, right? And this angle and this angle 90 degrees, so this angle must be theta, right? This angle and this angle must be theta. Okay, to find out this uh, r r e1 comma r e2, so we can find out that how we can do that. So we have to draw um, another so we can draw a rectangle here parallel to this and parallel to this right here. So this length and this length same. I'm sorry, my drawing is not so good. And this length and this length is the same, right? Okay, so we have to find out re1, right? So what is re1? Re1 is the amount of this one, a to x, right? A to x here. So what is ax? Ax is nothing but if we point it, say it is say y, then we can write down ay plus xy, right? A plus xy. So what is the ay? Ay is nothing uh, uh, but x e1 cos theta, right? So we can write down e1 cos theta, because here the e1, right, and this is the 90 degree angle, 90 degree angle, so this is the base, right? So we can, so this amount of is ay is equal to this amount of e1 and this theta. So e1 cos theta plus what is the xy? What is the xy is nothing but this amount of, right? So this amount and this amount is same. So we have a theta, so we can write down the x sine theta. That means e2 sine theta, right? e2 sine theta. So what is the e2? This amount of is e2, right? Yeah. So similarly, we can find out. Similarly, you can find out this. For example, here, we have to find out this amount of bx, right? So what is the bx? Bx is the this amount bx equals, so if you say it's z, so bz minus bx, right? So what is the bz minus uh, bx? So bx is nothing, bx is nothing because you have theta, so we can write down here we can write down is e2 cos theta minus, because you have minus, so what is the bx? So this amount of bx, right? So bx is nothing but e1 sin theta, e1 here, and this amount and this amount is the same, right? So we can write down this e1 sin theta. So what we can write down here, so from there we can write down here, so we have got here say re1, so x equal to nothing but re1, right? So re1 equal to x, and bx equal to r e2, and we know r e3 equal to e3. So what is the components of re1? re1 component is, so we can go down and write the matrix of that. Components of re1 equal to, so we can write down here cos theta, here the sine theta, and we do not have any e3 components, so 0. So here we have so e1 is here, so minus sine theta, here is the cos theta, and it is 0. So we have in e3 component r3 0 0, and it is 1. So this is our, and this is the rotation matrix or something like that. And here we have e1, e2, and e3. So this is the rotation or something like that, rotation matrix or something like that. Okay, so thank you. I hope you have enjoyed this class, and in the next lecture I am going to teach you all about how we can derive a component of from a or transform derive a components of a transform vector, something like that. Okay, hopefully see you on next lecture. Thank you.